Hey, what's up, Gomez gang? Today we're going to talk about an intervention worksheet that I gave out earlier. They all require you to write an equation to help you solve. So it is extremely important that before you even rush into doing some calculations, you make sure that you write an equation that is perfect. Again, writing the equation is half of the credit that you will receive. Getting the correct answer from that equation is the other half. So you need to make sure that you're doing this correctly. Odette took a taxi from the airport. The taxi fare was $2.10 per mile, and she gave the driver a tip of $5. At the end, she paid the cab driver $49.10. They want to know how far Anne's home is from the airport. How far it is, that's the question. It's a number of miles. We need to find out what that number of miles is. I don't know it yet. I'm going to use a variable, number of miles. Great. I know that I paid $2.10 for each mile. So regardless of how many miles this cab travels, if it's 1, then it's $2.10 times 1. If it's 18, it's $2.10 times 18. It does not matter. This is the cost per mile. Some of you guys would leave it at that and not understand what 2.10 M actually represents. And 2.10 M itself, if you wanted to represent it, would be the cost to drive M miles, right? Of course, that's not the only price that Odette is paying. She's also paying $5 for a tip that she is giving to the cab driver. When it's all said and done, it's $49.10. That is my total cost. That is the equation that I am looking for. Now, of course, to solve, subtracting 5 from both sides, you're left with 2.10 M is equal to 44.10. At that point, it's just getting our variable by itself. We need to do the inverse operation here. I'm doing 2.1 times M. I'm instead going to divide both sides by 2.10. And when it's all said and done, M is equal to 21. Odette has to drive 21 miles to get from the airport to her house. That is question 1. And I'm breezing through this because I'm expecting you guys to understand it by now based on the work that we've done in class already. We'll move on to question number 2. Question number 2 says, Kona added 2 expressions together and got 9x minus 15. So I have 2 expressions. I don't know what they are just yet, but when I added them together, it's 9x plus 15, minus 15. One expression was twice as large as the other. I don't know which one either one of them is. And I don't want to use x because I'm already using x in this equation. So instead I'm going to use y. And y I'm going to say is the smaller of the 2 expressions. And if I know that one is smaller and the other one is twice as large, then I'm going to say that this one is 2y. That is the larger expression. So y plus 2y is equal to 9x minus 15. When I combine y and 2y, then I have 3y is equal to 9x minus 15. Of course, my goal is to get y by itself. Divide both sides by 3. That means that y is equal to 3x minus 5. That is my smaller expression. The larger one would be 2 times as big as that. So 2 times 3x is 6x minus 2 times 5 is 10. And when I add these both together, I have 9x. If I'm subtracting 5 and subtracting 10, that means that I'm subtracting 15. So I have 9x minus 15. These are my 2 expressions that match.